Hey everyone, and welcome to AC Academy. Today we're going to focus on Algebra 1, Section 2.1.1, and that's Exponents and Radicals. So let's step right into it. First question states, write an expression equivalent to the following. We're going to break this into three parts, A, B, and C. So A is the square root of 147. Let me zoom in so I have a little more real estate whenever I'm making problems. All right, let's go ahead and put the square root symbol there. Okay, so first thing, whenever you're doing these problems, it's pretty straightforward if you break it down like this. So you look at the number inside, and 147 is a bit of an awkward number. But what can you divide 147 into? Is 147 divisible, right? So you can use your calculator here. 147 divided by, let's say, 3, right? Which it is divisible by 3. So we have 3 times 49, right? Now going from this step to this step, how would you figure that out? Some of it's just a little bit of mental math that you have to know, but one thing that I do, I look at these numbers kind of individually, right? So I look at the 7 number, and then I look at like 100. If we were to imagine 140, right? And I try to come up with factors, or I try to like cross out factors that will not go into this, like off the top of my head. So we know that the number ends in 7, so 147. So we can't use any even numbers, right? It has to be some sort of odd number times an odd number. Okay, so first thing I do, so you're not going to do 1 in 147, so I step up to the next number, 3. How many times can 3 go into 147? And this time it looks like it's 49 times, right? If 3 couldn't, I'd step up to 5, to 7, 9, so on and so forth, right? But we got 3 and 49 here. Okay, now what is 49 divisible by, right? It's 7 times 7. So 7 times 7 equals 49. All right, so now this and 7 you can't divide. 7 is going to be 1 times 7, and that's it. So 7's a prime number, they would say. So once you get to this point, you have a 3 here, and you have 2 7s here. What do you do after this point? What you want to do, this is the same thing as 7 squared, right? 7 times 7 is the same thing as 7 squared, which is equal to 49. So right now we have square root of 3 times, let's say, like 7 squared, right? That's what we have here. That's equivalent to this, since we broke down and got these two numbers. We got 3 and we got 7 squared here. So you have the square root, and you have this number, and you have the squared number here. So what we want to do is factor one of these numbers out to simplify this radical here. You have a square root and you have a square. So these would cancel out, and you would be able to move this outside. Okay? So this would be the same thing as 7 radical 3, right? Because whenever you're moving across the square root, you either have to square it or you have to square root it, right? And here we got the 7 squared. We took the square root of 7 squared. So like a side step here would be, and then we want to move it out here. So we have to like square this, or sorry, square root this, take this out, and then we move it out here and we get the 7 outs here, right? So for A, we get this. 7 radical 3. Right, let's take a look at B. And again, if there's any questions, go ahead and put them in the comment section, and then I will get to them as I see them. We have the square root of 135. Okay, 135, again, let's look at this number. We have 5 on the outside, right? So that's the first number I'd go to, because, 5 times whatever it is, you have multiples of that. And you just kind of go from there, right? So What can we divide 135 into? So we know 5 is going to be one of the numbers, right? Because 5, 10, 15, all those numbers are going to end in 5, right? And what is the next number? So 135 divided by 5 is 27. So we have 5 and we have 27 here. So what can we divide 27 into? We could divide that into a 9 and a 3. This 9 can also be a 3 and a 3, right? Okay, so now that we have that, we have this whole tree, and let me scroll down a little bit. We have 3 squared here. We have a 3. And we have a times 5 here. Right. So what we want to do, again, if you want to move it across the square root, you have to square it. And without getting into weird fractions outside of here, we'll focus on this number. The same thing we did up here with this 7, we're going to do with this 3. So we're going to square root this 3 squared. And it's going to be, we're going to move this outside after we square root it. It's going to be 3, 5 times 3. Right? And then this is going to be the same thing. It's 3 radical 15. Right? So that's B there. Let's look at C. C is going to be the square root of 96. Okay, so how many times can we divide 96, right? So let's start at 2. So 2, and then 96 divided by 2 is going to be 48. 48, right? How many times can we divide 48? Let's start at 2. 48 divided by 2 is 24, right? 24. How many times can we divide 24? We could do 6 times 4. Yeah, let's do 6 times 4. 6 times 4. And that is about it. Okay, so what is this equivalent to, right? So we have a 2, and sorry, let me scroll down a little bit. We have a 2 times 2 times 6 times 4, right? So there's 2 times 2, and be careful on this part. So this 2 times 2 is 4. We have a 6, and then we also have a 4 here. So this would be the same thing as 4 squared, right? Because this is a 4. We have a 4 here. Times 6. We'll throw that in a radical. And that would be the same thing. So focusing on this 4, we have 4 square root of 6. Or 4 radical 6. Okay. Let's take a look at those before we go on to the next question. Okay, so let's focus on this one, 2a and 2b. All right, so 2a, write an expression equivalent to, and I'm going to write this out. So x cubed times x to the minus 17 in the form of x to the n, right? Okay, so we could do, one thing you can do, is, so you have this negative exponent here, right? So that's going to be the same thing, and this is a rule that you should learn. It should be the same thing as this, right? Or you don't even have to put it as this. Whenever you have exponents, and you know that x is the same here, you can simplify it such that these exponents are added or subtracted to one another. So x to the third times x to the minus 17 is the same thing as x to the 3 minus 17, which is the same thing as x to the minus 14, which is the same thing as 1 over x to the 14. Okay, so let me walk back through that. This is 2a. We have the question here, and let me use a different color. We have the question here. Right, so x to the third times x to the negative 17. That is the same as this, just because this exponent is negative, so you can move it to the denominator and make it positive. So x to the third times x to the 17 is the same thing as x to the 3 minus 17. So the two exponents, right? And that will give you x to the minus 14, which is the same as x 1 over x to the 14. Right, so here's our answer for 2a. Okay, let's look at 2b. Write an expression equivalent to, let me write this out, 7x to the third squared times x to the eighth. This is 1/2. Okay. So this would be the same as one way that people mess up doing this problem is they'll see this exponent and then they'll just only apply it to this part right here. But what this is really equivalent to is 7x to the third times 7x to the third, right? So you have to remember both sides. Okay? So first thing you want to do, like I said in the previous problem, you want to add these exponents. So this will be the same as 49x to the 6. Right? So you have this, 7 times 7 is 49. Or, yeah. 7 times 7, 49. And then you have x to the third and x to the third. This is the same thing as, for the x portions, x to the 3 plus 3 gives you x to the 6. And then you just multiply that 7x to the third times 7x to the third, and that gives you the 49 up front right there. Okay, so let me box that one right here. Okay. And then I almost forgot this second part. Second thing here, whenever you're multiplying, whenever you're going from this out here into here, you're actually multiplying. So it's an exponent to an exponent. So in this case, it would be 8 times 1/2, right? So this would be x to the 4, right? So now we have, and let me repeat that because I went through that pretty fast. Whenever you have an exponent, so x to the 8th to the 1/2, you have to multiply this exponent by the exponents inside here. Right, so it's not the same as x. Let me write this in red or orangish. It's not the same as x to the 8th times x to the 4th. These you would add, and that would be x to the 12th. This is x to the 8th. I'm going to do it in this case to the 4th. So that would be equal to the x to the 32. Right, so just kind of remember this, and we're applying those here. Okay, so this will be x to the 4th. So right down here, it would be 49x to the 6 times x to the 4th. And since these two are added here, we get x to the 10th, right? 6 plus 4, 10. Boom. All right, cool. Well, thanks for watching and going through this. If you have any questions, go ahead and put them in the comment section, and I'll get to them as soon as possible. Again, pay attention to some of these rules, like I put in red, and know the difference between if your exponents are on the same level here, or if your exponents are to another exponent, and then we can know the difference between adding them and then multiplying them together. Anyway, thanks for watching, and then I will catch you all in the next one.